Hello class. Today we're going to continue talking about algebra and numbers on the topic of measurement. All right. Now, one thing that we need to talk about is SI. All right. So this is the abbreviation for the International System of Units. Now, we have 7 base units for length. The base unit is the meter, and the abbreviation is M. For mass, the base unit is actually the kilogram, and that is kg. For time, it's the second, which we say is S. Electric current, that is the ampere, which you may know as amps, capital A. Now, it's really important, guys, if a number is lowercase in the abbreviation, keep it lowercase. If it's uppercase, keep it uppercase. Otherwise, you change the meaning. For temperature, it's actually the Kelvin, which is uppercase K. Amount of substance is the mole, which you may remember from chemistry, which is abbreviated MOL, which doesn't seem like much of an abbreviation, but there we are. And then for intensity of light, we have the candela, which is CD. So in the International System of Units, there are other units which we call derived units. So area, for example, would have the square meter, or m squared. For volume, we have the cubic meter, or m cubed. Meters per second would be speed or velocity. And this is ms to the -1. Now, we know that a negative exponent would place something on the bottom of a fraction, so that is the same thing as m over s, meters per second. And then for mass, or density, what we look at is kilograms per cubic meter. And that would be your kg, and then per meter, per cubic meter would be m to the -3, because of course that with exponent rules comes out to kilograms over cubic meters. All right. So for us, the big ones that we want are meters, kilograms, and seconds for our base units. And then we will be using basically all 4 of the derived units. Then we have the prefixes that go with the International System of Units. So let's write down our SI prefixes, and we're going to use these to move back and forth between different derivations of our base unit. So we have a factor that we multiply by. We have the prefix, and then we have the symbol or abbreviation. So if we're multiplying by a factor of 10 cubed, the prefix is kilo and the symbol is K. That's how we know that a kilogram is 1 gram multiplied by 10 to the third, or 1,000 grams. A factor of 10 to the second gives us hecto, or H, and a factor of 10 to the 1 gives us deca, or da, D-A. A factor of 10 to the negative 1, which would be 1 over 10, is deci, which is lowercase d. A factor of 10 to the negative 2 is centi, or C. And finally, a factor of 10 to the negative 3 is going to be milli, or lowercase m, not to be confused with the lowercase m for meters. So if I'm doing conversion factors, all right, if I'm trying to convert 1 decimeter to meters. All right, well, I know that 1 decimeter is equal to 10 to the negative 1 meters, or 1 decimeter is equal to 1/10 of a meter. What if I was doing 1 decasecond and converting it to seconds? Well, I know that 1 decasecond is equal to 10 to the 1 seconds. So 1 decasecond equals 10 seconds. All right. So let's talk about doing a few more conversions. Got to turn my page here. If I'm converting, let's say 2.8 meters, and I'm going to convert that to hectometers. All right, well, I know that 1 meter is equal to, well, I know that a hectometer is 10 to the second meters. So I can flip that to say that 1 meter is 10 to the negative 2 hectometers. Now, because of that, I can take 2.8 and I can multiply that by 10 to the negative 2. And that's going to be how many hectometers are in 2.8 meters. If I were going to do something like 3,200 milliseconds 3,200 seconds, let's go this way, to milliseconds. Well, I know that 1 second is 10 to the third milliseconds. So I'm going to do 3,200 times 10 to the third milliseconds. If I want to make that a little neater, I need to move that decimal place 1, 2, 3 more places and make it 3.2 times 10 to the 6th milliseconds. And finally, let's take a look at half a kilogram. And let's convert that to a decigram. All right. Well, I know that a kilogram is 10 to the third grams, and a decigram is 10 to the negative 1 grams. So they're actually 4 units apart. So because I know that 1 kilogram is equal to 10 to the 4th decigrams. All right, so 0.5 kilograms times 10 to the 4th decigrams. But to write this a little nicer, let's move that 1 space this way. So I have 5 times 10 to the 3rd decigrams. So that's our basic unit conversion. Now, when we're dealing with area and volume, and we're doing that conversion, then things become a little more interesting. So if I have a cube, actually no, we'll start with a square. I have a square. All right. And this is 1 meter by 1 meter. To get the area, I multiply length times width. 1 times 1 is 1 square meters. All right. Well, what if I want to convert that area to, let's say, decimeters? Well, I can't just do the conversion factor here because this is meters squared. So I know that the same cube is going to be 10 decimeters, and 10 decimeters, length times width, gives me an area of 100 square decimeters. So, how is this going to work? Well, I know that 1 meter is equal to 10 decimeters. Therefore, 1 meter squared is equal to 10 decimeters squared, which is 100 square decimeters. I hope that makes sense. Let's try it with volume. Okay, so now I've got my cube. And it's 1 meter by 1 meter by 1 meter. So my volume is going to be 1 cubic meter. Moving that over to decimeters. Again, making my cube. And so now I have 10 decimeters by 10 decimeters by 10 decimeters. So 10 times 10 times 10 is 1,000 cubic decimeters. But does it work the same way? Let's try. I know that 1 meter is equal to 10 decimeters. So 1 cubic meter, is that the same as saying 10 decimeters cubed? Absolutely. 1,000 cubic decimeters. It gives me the same answer. So this is a good way to practice conversion factors. Now, America has an imperial system that really we don't include in the SI, or International System of Units. However, we do have some non-SI units that are accepted because they are widely used in everyday life. So, non-SI units accepted in the International System of Units. There's only a few of these. For time, we do allow for the minute, which is MIN, and is equal to 60 seconds. We do have the hour, which is H, which equals 60 minutes, or 3,600 seconds. We even have the day. And day is D, which is 24 hours, which if we convert that then is 86,400 seconds. For area, we do allow for the hectare, which is HA. And so that is one, that is 1 hectometer squared, or 1 square hectometer, which would be equal to 10 to the 4th square meters. For volume, we allow for the liter, which is spelled like it is in Europe, which is capital L, or this fancy little cursive L, and is equal to 1 decimeter cubed. And then for mass, we do allow for the ton, which is equal to 10 cubic, or 10 cubed kilograms. All right. We also do have 3 temperature scales. Don't want to start a whole new page just for these, so I'm going to put them over here. So in addition to Kelvin, we have Celsius, that's an S, and Fahrenheit. Now these are very different in the temperatures at which they freeze water and at which they boil water. So at 32 degrees Fahrenheit, which is 0 degrees Celsius, water freezes. At Kelvin, that happens at 273.15 degrees. Water boils in Fahrenheit at 212 degrees. In Celsius, that's 100 degrees. And in kelvins, that's 373.15 degrees. Now, we have our formula to convert from Celsius to Fahrenheit and from Kelvin to Celsius. So, we have, starting with Kelvin, the temperature in Celsius is equal to the temperature in kelvins, minus 273.15. The temperature in Fahrenheit can then be found by taking 9/5 of the temperature in Celsius and then adding 32. And these can be used to convert back and forth between the different types of temperature measurement. Now it's time for some practice.